So everything that we did yesterday was just a one-step equation. You either had just multiplication, just division, just addition, just subtraction. Now we're going to have it where you have multiple things in there. When you have things like this, you have to always think that you are trying to get the variable by itself. And so you're going to do whatever you need to do to get the variable by itself. And normally you're thinking order of operations, but when you are solving, you are going backwards. So you're actually kind of going to do it backwards. You're going to do your addition and subtraction first, and then you're going to do your multiplication and division. All right? And so you want to think of it as order of operations kind of backwards. You're getting things away from the variable. And you want to always start with something that doesn't have a variable at all. So look at the top of page 69, example 1. All right, for this example, we have 2x plus 6 equals 21. My goal is to get the x completely by itself. And so when I have this equation right here, I want to get rid of the 6 first because it does not have an x. So I will get rid of the 6 first. Then I'll just have the 2x and I'll get rid of the 2. All right, so we're going to start with the 6. What is happening with that 6? What is going on here? Between here and here, what's happening? What is this guy? This is addition. And so what is my inverse operation here? Subtraction. So I'm going to subtract 6, subtract 6. With addition and subtraction, you are trying to zero it out. So if what you did not zero it out, you did it wrong. This should always zero when it's addition and subtraction. So we have a positive 6 and a negative 6. That will zero out. And so I have that right there. All right. So that means on the left-hand side, what I have left here is just a 2x. Make sure you bring down your equal sign. And then on this side, we're just going to subtract. What is 21 minus 6? 15. All right. So now I have a 2x by itself. What's going on between the 2 and the x? Multiplication. So that means I'm going to divide. With division and multiplication, your goal is to make it a 1. 2 divided by 2 is 1x. So here I just have an x. I need to divide both sides. Make sure you bring down that equal sign that you always know where it is. So your answer here would be 15 halves. You can actually leave it like that for me. You don't have to make it a mixed number. You don't have to make it a decimal. All right, so if I take this, I would just plug it back into my original, and I would say 2 times 15 over 2 plus 6 equals 21. I will say that plugging it back in, it's easier as an improper fraction, because since you're multiplying, you would have to convert it back anyway. 2 over 1, right? So these cancel, and I have 15 plus 6 equals 21. Is that a true statement? Yeah. Yes, it is. So that means this is my answer right there. Two-step equation. All right, let's look at a little bit more difficult one. Look at example 2 right below it in your books. Example 2. All right, so for example 2, you'll notice they threw in some decimals here. All right. You'll also notice that I have a subtraction here and I have division here. I'm still going to do this part that does not have an x at all. So this is a minus 3.6. What is my inverse operation here? Yeah, I'm going to add 3.6. So I'm going to add 3.6 to both sides. Now here is where you want to pay attention to what's happening with your decimals. All right, on the left-hand side, I still have the a divided by 1.5. You do want to bring down that equal sign. Right here I am, I have a negative and a positive. So remember, when I have a negative and a positive, when I'm adding, I'm just going to subtract, and I will keep the sign of the larger, right? And so I'm going to subtract these. I have a 4 minus 6. What do I need to do? This little borrow guy, right? That makes more sense. 14 minus 6, what is that? It's just 8, right? And then don't forget to bring down this decimal right here, okay? 3 minus 3 is 0. Is this a positive or a negative 0.8? Negative, because my 4.4 right here was negative, so that's a negative 0.8. So I now have a over 1.5 equals negative 0.8, all right? What is happening here between the a and the 1.5? Division. So what do I need to do here? I need to multiply. So I am going to multiply both sides here by 1.5, all right? So this is multiplied by 1.5, all right? On the left-hand side, 1.5 over 1 times something over 1.5. Those are just going to cancel, all right? So you just have an A there. How do I do this guy? How do I multiply 0.8 and 1.5?
Get rid of the decimals and then just do the
Just multiply. So I'm going to say 1.5 times 8, all right? Just ignore the decimals, right? 8 times 5 is? And 8 times 1 plus 4? 12, right? And then you go back here and I say, well, how many decimals did I start out with? 2. 1, 2. So that means I am going to put 2 decimals in, 1, 2. So A is going to equal 1.2. Is it positive or negative? I multiplied a negative times a positive. It's negative. Negative 1.2. Negative 1.2. So when you're doing this, you have to consider your rules for adding and subtracting positives and negatives, your rules for decimals and fractions, and your rules for multiplying and dividing positives and negatives as well. All right, you have to consider all of that. Undo the addition and subtraction first, and then go and do your multiplication and division. You're trying to get your variable completely by itself. So look at that last example on page 69, example 3. All right, so following these steps here, what's my first step? What am I going to do first? I'm going to add my 7. So I add 7 to both sides, all right? On the left-hand side, my positive 7 and my negative 7 should zero out, and I have just x over 3. Bring down your equal sign. On the right, I have 2 plus 7, which is just 9. All right, so 2 plus 7, we get 9. All right, now, what is happening between the x and the 3? Division. So what am I going to do? Multiplication. When you multiply here, you're going to multiply both sides. On the left, these change to 1x. And on the right, I have 9 times 3, which is 27, which is my answer. I can check it. 27 over 3 minus 7 equals 2. 9 minus 7 equals 2. That is true. My answer is correct. All right, so go ahead and try. All right, so for number 8, this is a little bit different. It started with a 4 and then plus y over 6. You always want to get rid of what doesn't have the variable in it first. And so this one is a 4. It doesn't have a plus or minus in front of it. So we're going to assume that it's positive. If it were negative, it would have a negative in front of it. So we are trying to make this 0. So if we have a positive 4 and we want to make it 0, we're going to subtract 4. So this is why I subtracted 4 here. We want to make this 0. Because I subtracted 4 here, I need to subtract 4 here. So on the left-hand side, my 4 is zeroed out, and I have just the y over 6. On the right-hand side, 9 minus 4 was 5. So then I have y over 6 equals 5. This is division. So I want to multiply both sides by that 6. On the left-hand side, these turn to 1, so I have just 1y. On the right-hand side, I have 5 times 6, which is 30. And then I just checked it. 4 plus 30 over 6, 4 plus 5, that is 9. So we're going to look at word problems. This is going to be how you approach a word problem really forever in math. This is just the way that you do it. First, you want to read the problem. It's very important that you read the whole problem, all right? Look for operational words. What they mean by that is any of those keywords that are telling you they're adding, subtracting, multiplying, or dividing, all right? If it is something you can draw a picture for, like if they have a rectangular flower bed, well, you might want to draw a rectangle so you can get a visual of what you're trying to solve for. Assign a variable. So when you figure out if it says a number, then you want to assign a variable to represent that. If it says the number of hot dogs, then you want to assign a variable for the number of hot dogs, and you want to label it as to what you're talking about. The next thing you want to do is plan a method of how to approach this. This may be translating it into an algebraic equation. This may be making a table if you have several different things going on as we get further along. Once you have your equation set up, then you just want to solve it, just like we've been doing for the first 3 examples. So once you set up an equation, you're just going to solve it. Add or subtract your number over, multiply or divide to solve. And then you want to check your solution. Now with a word problem, this is a little bit different. You want to plug it back into your equation and make sure that works. But you have to consider the fact that you set up the equation. And so you also want to make sure that your answer makes sense, all right? Like I gave the example. The person that gave me that they were in a boat going like 600 miles an hour, that did not make sense because boats don't go that fast. That's what airplanes do, okay? And so you want to make sure that your answer is reasonable. You don't want to give me -3 when you're talking about hours, because that doesn't make sense that you traveled for -3 hours, right? And so you want to make sure that you have a logical answer based on what your word problem was talking about. All right, so let's look at the first word problem here, example 4. 97 is 23 less than 4 times the number. Find the number, all right? So let's look for our key things here, all right? We have a number, that's easy. How are we gonna write that? Well, we're just gonna write that as 97, right? And then we have a key word here, is. What did we say is always means? Equals, so I'm gonna write equals. And then they give us another number, 23 less than 4 times a number, all right? So what is it, if it says less than, what operation are we likely going to use there? We're going to use subtraction. Which one are we going to subtract from, though? If I said you are 3 years younger than your brother, you would take your brother's age and subtract 3, right? And so here this is saying 23 less than 4 times a number. So 23 is what we're actually subtracting. So what are we subtracting it from? We're subtracting it from 4 times a number. So how do we write 4 times a number? Yeah, a number is going to be x, right? So a number is x, and we have 4 times. So we are going to write 4 times a number. And it is 23 less than that. So we're going to then subtract our 23. Less than indicates that we're going to subtract. And of course, 23 is the number that they gave us. All right. So we have set up an equation. All right. We have read the problem. We've pulled out our operations that we have. And now we're just going to solve it. So what is my first step in solving here? Right. I have a subtracting 23, so I need to add 23. It doesn't matter what side the variable's on. We're getting rid of things that are with our variable. We want it by itself. So here we're subtracting 23. We are going to then add 23 to both sides. So I'm going to add 23 here, and I'm going to add 23 here. All right? On the right-hand side, the 23's cancel. A negative 23 and a positive 23 zero out. That's what we want. So we're left with just a 4x. Don't forget to bring down your equal sign so you don't get confused about what you're doing. And then we have 97 plus 23. What is 97 plus 23? It's 120, right? So don't forget to carry. So we have 7 and 3 is 0. Carry that, and then you have 12. All right? So now, what's going on between over here? What's happening? Multiplication. So what do I need to do? Divide. So I'm going to divide both sides by 4. On the right-hand side, 4 divided by 4 is 1x. Don't forget to bring on your equal. Now, what is 12 divided by 4? 3. So then 120 divided by 4 is 30. All right, so it says 30 equals x. Remember at the very beginning, we had a property called symmetric, right? If a equals b, then b equals a. So it doesn't matter that it's written that way. That's the same thing as saying x equals 30. All right, does this make sense? Well, is 97, 23 less than 4 times 30? What is 4 times 30? 4 times 30 is 120. 23 less than that. Well, let's subtract 23. We got to carry, right? So we get 10 minus 3 is 7. 11 minus 2 is 97. Yes, my answer makes sense. All right, makes sense? Good. All right, for this one, it says how many quarters must be removed from 264 to leave a total of 189? All right, so what am I starting with? How much money am I starting with? $2.64. I am removing. How do you think I'm going to remove money? Addition, subtraction, multiplication. Yeah, subtraction, right? So I'm going to subtract. And this says how many quarters. So what am I solving for? The number of quarters, right? So I want to tell whoever's reading this, so if I'm looking at what you did, you need to say that x equals the number of quarters. All right, so you need to tell me what your variable represents. All right, what your variable represents. Now, if I remove the number of quarters, how do I know how much money I am removing? How much is each quarter worth? 25 cents, all right? So in numbers, I'm going to write that with a decimal, right? I'm not just going to write cents because the other one's in decimals. So for the number of quarters and how much money that is 25 cents times my number of quarters, right? That's how much money I would remove. Now, how much do I want left over? $1.89. And so that should equal $1.89, all right? So now I have my equation. How do I solve it? I need to get rid of everything that is not with the x, right? So I need to move everything away from the x. What's the first thing I'm going to move? Right, it's a positive 2.64, so I need to subtract it to zero it out. So I'm going to subtract 2.64, all right? On the left-hand side, those zeros. Now here we go. I am left with negative 0.25x. You must, when it is a negative, bring down the sign with it, okay? You have to bring it down or your answer will be wrong. All right, bring down your equal sign. Now let's look over here. I have 189 minus 264. How do I do that? I have a positive and a negative. I have a positive and a negative. This is a positive 189, a negative 264. I'm just going to subtract those. So I'm going to say 264 minus 189, all right? You are going to have to do some borrowing here, right? So we have to borrow here. 14 minus 9 is 5, hopefully. Yes. 15 minus 8 is 7. And then make sure you bring down your decimal. And then because this was the larger and it was negative, that's a negative 0.75, right? Negative 0.75. So my last step here is what? Right, so I am multiplying that x over here. Right here I have 0.25 and x, that's multiplication. So I need to divide both of those by negative 0.25. Negative 0.25, all right? Now on the left-hand side, I now have my x. I'm dividing these decimals. Now, when you divide decimals, you can just move, if they're the same exact decimal place, so I have 2 decimals up here and 2 decimals up here. When you divide, you actually move by what you're dividing by. So I can actually move this 2 decimal places and this 2 decimal places. Because that's really what you do when I divide, right? 0.75 divided by 0.25, I would do this, wouldn't I? So what is 75 divided by 25? It's 3. And I have a negative divided by a negative. So what is my answer? Positive. So my answer is 3. 3 what? It's a word problem. 3/4. That is what I was solving for. So 3/4. Right, but it asked for the number of quarters, right? The grain elevator weighed Mr. Young's truck at 17,760 pounds before he dumped his wheat. The weight of the empty truck is 6180. If the wheat weighed 60 pounds per BU, all right, how many bushels of wheat did he deliver to the elevator? So each bushel is worth 60 pounds. They want to know how many bushels he delivered. So what are we looking for? What are we looking for in this problem? Look for the question. How many bushels? All right. How many bushels? Here's your question right here. How many bushels of wheat? So that is what my variable is going to be. When they have a question, how many, that's your variable. And so your variable here, so your X here is going to be bushels of wheat. That is your variable. Okay. So how much did this truck weigh initially with the wheat and everything?
17,000.
Right, so 17,760. That's how much it weighed. All right. He dumped wheat. Did he add or subtract weight when he did that? He subtracted weight. All right. We don't know how many bushels, but we know how much each one weighed. How much did each one weigh? 60. So how do I know the total weight of the wheat? You multiply, right? 60 times however many bushels he dumped. We don't know how many that is. We do know how much it weighed after he dropped all that wheat off, right? And how much did it weigh then? Yeah, so how much it weighed was 6,180. All right, 6,180. Okay? Do you see how we set up the problem? Initial weight minus how much he got rid of, and then equals the total weight at the end. All right? We know that it was 60 pounds per bushel because they told us that. Anytime it's a per amount, it's going to be multiplication, right? Price per gallon, you're going to multiply how much it costs times how many gallons, all right? So how do I solve this? Right, we're going to subtract this guy right here. It was positive. We need to get rid of it, make it 0. Because I did that, I'm going to subtract it over here. All right, now here we're going to do exactly what we did before. We have a positive and a negative. When you are adding with positives and negatives, just subtract the smaller from the larger. So just take the 17,760. Oh my goodness, nobody caught it. Here we go. You did? You're supposed to say something. There we go. Let's try this again. That is 11, by the way. There we go. He jumped ahead of me and then didn't find it. All right, now, much easier. He jumped ahead of me and then didn't tell me. All right, this is going to work out much prettier, I promise. Everybody gets to erase. 6 into 11. There we go. 1. 6 into 55.
9.
Right. 6 into 18. There we go. That's much prettier, isn't it? We were going to get a decimal. All right. 193. What does that tell us? When you solve, go back to your variable here, right? How many bushels of wheat he dropped, which was a whole bunch of wheat, by the way.